Today we're going to look at LeetCode problem 208, implement trie or prefix tree. So a trie is a prefix tree that is a special kind of tree. It's a tree data structure that officially stores and retrieves keys in a data set of strings. So basically it's a special kind of tree where we can insert words, look up words, and stuff like that. There are various applications of data structure such as autocomplete and spell checker. So in this question, we want to initialize a trie object, be able to insert a word in this trie tree, and it's going to be a string, be able to search for this word, and be able to see if any word starts with some kind of prefix. So if we have this example here, we initialize the trie and insert insert apple, and then we search for the word apple. It should obviously return true. We search for the word app. We don't have app. We have apple, but we don't have app, so we return false. We check starts with. Are there any prefix words with the prefix app? We do, so that returns true. And then we insert app. We actually insert the word app here and then search for app, and then that should return true. So how we're gonna do this is obviously it's gonna look like a tree structure. So when we initialize, we're gonna look at these functions here. So when you initialize trie, it's originally gonna be a structure where it's just gonna be empty here. Okay. And then when we insert, we want to insert in this structure. We're going to insert, so with this structure, so we're going to initialize a node first. So we're going to have nodes that store these various words. And for each word, we're going to have, for each node, I mean, we're going to have two properties. Children and a bool that's going to be called is end. So when we go to insert a word, we first check in this trie, does the first character of this word exist in this trie? So first insert an apple, does A exist? No. Then we're gonna insert it into children here, and children could be an array or it could be a dictionary. I'm just going to use dictionary in my implementation just because it's one lookup and it's easier for me. So then when we go to, so this node here will have its own set of children and the is and bool. So is and bool will obviously be false. And then this will have its own set of children here. And then we'll insert P. And is this the end of the word? No. It's the is end flag is going to be false, and then so on and so forth. A, P, P, L, E. And this guy is and is going to be true. This is false. False. So that's for how we're going to go about inserting. And for searching, what we want to do is for the trie, start up at the top here, and for each character in the string word, we want to check, is it in children? So we first check A, is it in this trie? Here's a list of children. Yep. So we go to next character and this trie node's list of children. Do we have P? Yep. So we go next to that trie node's list of children. Another P. Yep. 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 And when we get to the last character here, we see this guy ends in E. And and since the is end is set to true here, we return true. The whole word apple is in here. Similarly, if we look for the word app, we traverse through the nodes and their children, and we see this guy's is end variable flag is false, so we return false. Now, if you want to insert another word like as, so we have apple, if we want to insert the word as, so we check here, does this try already have the prefix a? It does. So we go to this list of children. Does it already have a prefix, the letter S in its children? No. So we add this here, and its is end flag is true. Okay. And that's how we're gonna go about the insertion and search. And for starts with, it's pretty much similar to search here, except we don't have to check if this is end flag is true. It could be false, doesn't matter, as long as we know that there's a word that starts with this prefix. Okay, so now I'm gonna start coding it up, and all these operations of the try are at worst case O of n, where n is the length of the string in question. Okay, so let's start implementing this try here. Before we do anything, let's implement the try node. So, and initialize this constructor. Oops. Okay, and in this try node, as we discussed, it's going to have a list of its children. It can be an array if you want. I'm just going to have it be a dictionary because it's easy O1 lookup. And when I talk about the array, it could be an array of length 26 because this is only consists of lowercase English letters, so and most is going to be 126, and if it has a child at the position like a position 0, if it has a child at position 0, then you can set it to, I don't know, 1 as the flag for true. But I'm just going to use a dictionary because I prefer it. Self, and then the is end flag is going to be false initially when we create this try node. Okay, let's look at the try class itself. So in the constructor, we're going to initialize a single try node. Self dot root is equal to try node. And initially this node will have an empty list and its is end is set to false. That's fine. And then for insert, what we're going to do is iterate through the try object. Now, okay, so for each character in the word, if the character already exists in the current node's list of children, if it already if it doesn't exist, that's what I meant to say, if it doesn't exist, then we want to add it. So in this list of children, so current node.children I is equal to try node. So as we saw for a try node here, at first we had a blank slate. When we initialized it, we had a blank slate here, and now when I with a empty list of children. And now in this try node we have a single element A. If we look at the example apple, and this A, initialized as a try node, has its own list of children here. And then it will be, as we iterate through the characters in the word, it will be P, and then this will have its own list of children, and so on. Okay. So in this dictionary, we would find, char, as A having its own dictionary. We map A to this try node, to this list here. And then we're just cur is equal to cur.children at this character. Okay, so we inserted A. Now we move on to the node. Now we'll move on to current node. Current node of A. Now we'll move on to A. Okay, and then finally, once we inserted everything, we're going to set cur is obviously going to be at the current node is obviously going to be set at the very last character of the strings. So like here. Finally, what we want to do is set that flag, that is end flag, to false or true. True. Okay. And that's how we're going to insert. And for search, it's pretty much the same thing as up here. I'm just going to copy paste that here with a few minor tweaks. So we're going to set it to the beginning of this try here at the root. So for each character in Word, if the character is not in the current node's children, just simply return false. Yeah, and then pretty much it, and then we'll move on to the next try node of so if we have apple here, we see that if we're searching for the word apple, we see that this try does have the word A, so we're going to move on to the A's list of children. Okay, and this end condition is going to be a little different. So right now, when we're done iterating through all this, the current node will stand at the very last character in the word, and if current node at end equals false, return false. Else will return true. And for it starts with, pretty much the same as this, except we don't have this condition here. We just want to make sure that the prefix exists in this try. Okay. Now let's try compiling it first. Valid syntax. Oh, it's not in. Right, I copy pasted it all. Not in. Prefix. Char word. Okay, there we go. Now let's try submitting this. And there you have it. That's how you implement a trie.